Hello everyone. I'm making this clip as the class could not be held today. So let us understand expected consumption and its variability. So this is important to understand how to draw constant expected consumption line. So as before, how to find expected consumption? That is simply the weighted average, and we have understood the weighted average, and using the same principle we can make the expected consumption, which is nothing but probability, which is probability of sunny state multiplied by what is your consumption in sunny state plus the probability of the other state of nature, which is hurricane, into what is the consumption during hurricane. So this way you get the expected consumption. And apart from that, there is one more concept called guaranteed consumption, which is nothing but consumption bundles, which the level of consumption does not depend on the state of nature, whether sunny or hurricane. We will draw both these lines, and to do so, we just take an example. Suppose probability of sunny state is 2 by 3, which is 66.67%, whereas probability of hurricane, which is 1 minus pi, which is the remaining one third, that is 33.33%. So using this expected consumption formula, in other words, the weighted average, we can draw the expected consumption line. Before that, understand expected consumption is nothing but the risky consumption bundles with the same level of expected consumption. Remember the word expected. Now we are working out the numbers so that we can draw the line. So let's go ahead with the same number that we, you know, uh, took example of, and the probability of sunny is 2/3, probability of hurricane is the remaining 1/3. So therefore, expected consumption is nothing but this. But what exactly will be your expected consumption? I cannot tell you that, right? So you have to assume how much consumption you want to have. In other words, you can assume that I want to have a fixed guaranteed consumption of, say, 500 units. It can be 500 rupees, 500 kg, or 500 some other unit, right? That's the number of units, or amount of money you want to spend on consumption. So I'm just plugging in that 500 in this formula. So therefore, EC is nothing but your 500 here, which is equal to the remaining portion in the term, right? 2/3 of consumption in sunny and 1/3 of consumption in hurricane. That will give you the expected consumption. Since our purpose is to draw the expected consumption line, so I will now ask you to do the following. In this, say this is suppose A. In equation A, you can assume the following two things one by one. So what will you assume? Assume first that this uh, Fs is nothing but your consumption in Sunny, suppose you assume that this is 0. Then what will you get from this A, the equation A? You will get 500 equal to 0 plus 1/3 of fx, right? 500 equal to 0 plus 1/3 of fx. In other words, you will get, you know, 1/3 of fh is equal to 500, right? fh equal to 500 because we are trying to determine the extreme points, right? In other words, fh is nothing but 1500, and this is quite easy because you will take that 1/3 to the other side. So this is understood. If that is the case, in the next stage, assume that now this one is suppose 0. So therefore the whole thing is going to be 0. And in that case, your this will not be 0 because you are not assuming that both are 0 at the same time because you are determining the extreme points. So here in the second situation, your outcome is 2/3 of fs equal to 500. And if you simplify it, what will you get? You will get fs is equal to 750. This is what is being written in this point. Okay, so this is what you got earlier. When fs equal to 0, fs is 1500. This is what is the first result, and second result is when fh equal to 0, your fs is 750, and fh is consumption under hurricane, fs is consumption under sunny state. And this one you must, contemplate. Now this is the result you have with you. Now let's plot this, right? So if you plot this, what do you have when fs equal to 0, right? When fs equal to 0, fs is 1500, right? So now if it is fs, because it is in sunny, right? fs equal to 0. This is the axis. When it is 0, you have a number called 1500, right? So this is what is given in your first result. This is your first result, right? Result 1, when fs equal to 0, you have fs equal to 1500. fs equal to 0, fs is 15. That means this point, this point. Now I'll again go to the second result. What is your second result? This is your second result, right? This is your second result. And second result says when your fs is 0, fs is 750. This is your fs in the vertical axis, right? This is because hurricane, that's why fh equal to 0. That means this side now is 0. Therefore, fs is said to be, we have 750, and this is not something we have randomly chosen. This is because of the probabilities you are working with and the guaranteed consumption you have assumed, that is 500. So in that case, your extreme point becomes 750, right? So if this is the extreme point, any linear combination connecting these two points will be your expected consumption line. And this is what you are supposed to work out. And remember, this is guaranteed consumption line, and this one is no matter, as stated before, no matter what is the state of nature, you will have some constant consumption levels, and it doesn't depend on state of nature. So in this example, 500 whether it is sunny or 500 whether it is hurricane, that is what is meant by guaranteed consumption. But this point is not in guaranteed consumption line, because in sunny it has less consumption, in hurricane it has more consumption. So is the case with this point, where you have more consumption in sunny state and less consumption in hurricane state. So guaranteed consumptions mean no matter what is the state of nature, if you want to have suppose 700 consumption in sunny, 700 consumption in hurricane, that will lie on guaranteed consumption line. So that is something guaranteed. But expected consumption depends on the probabilities, and therefore you are supposed to work out the expected consumption line following this example. And in your work you have to show, number one, what is the expected consumption line if probability of sunny is now half. Secondly, what is the expected consumption line if probability of sunny is 1/4, means 25%? And what is the expected consumption line if your probability of sunny is 75%, that is 3/4? These three are three different problems. You have to draw three different diagrams of expected consumption line, and you can assume whatever expected or guaranteed consumption you want to achieve. Just like this, in this case we started with an example of 500, that you can say keep the same or have any other number, but after assuming that number you can work out the consumption line, expected consumption line, using these probabilities given in question A, B, and C. I hope you have understood it, and I would like to receive your answers, and have a nice day.